if you can implement global numbering, then you have basically got function spaces. So that means you are able to represent as a piece of software the basis for a space which is over the whole mesh. So now we get into this nice mess that we will continue with for the rest of the module of switching constantly between global and local representations. So now we can write a function in a finite element space as a sum over the basis functions of a set of weights. But now, whereas up to this point we've always looked at one triangle and said, well, on one triangle it's true that a finite element function is a sum over the basis functions. This is global. This is a sum over all of the basis functions in the mesh. And depending on what polynomial degree we're at, some of those basis functions only exist in one element. Those are the ones with nodes associated with the cell itself. And if they're associated with edges, then they extend over two elements. And if they're defined on the vertices, then they extend over however many elements connect at that point. And so these are global basis functions. And the function space basically gives you that bit. It gives you the global basis functions over the whole mesh. And so a function in a function space, so a function is a horribly overused word, but by this we mean a function of space, a function of x and y in a finite element function space, is really just a function space plus this list of degrees of freedom. It's that simple. And that's great, but then we're going to start doing things with them. So we can see this, and in fact you don't have to implement the function class because it is just so trivial that I don't make you go through the steps. But you'll see that when you make a function, all it does is take a function space. It can also optionally take a name. The name has no mathematical function. It's only useful because if you have lots of functions flying around, it can be useful to be able to look at them in Python and work out which one was which. And if we look at the source, all we see is that a function is literally the function space you put in, the name, which has no technical function, and a set of degrees of freedom, which just start out being 0. So when you instantiate a function, it is the function which takes the value 0 everywhere, and that is equivalent to having fi 0 everywhere. And that's all that is. It's really, really simple.